All right, everyone. Today we're going to be going over a 6x6 PS50 configuration. So that is 6 inverters for 75 kilowatts and 300 kilowatt hours for energy storage. However, this system seems to be derated. So let's get started and let's take a look at the single line diagram. All right, and now on my screen you can see what I'm seeing. And so we will be going to get started here on the grid side. The main electrical room, we see 600 amp main panel with a line side tap interconnection that goes to an AC disconnect fuse switch to a load panel with two SMA 8000 inverters with a solar array over on the pool house. Cool, cool. We will not be touching that on the Savant side. So you see the 600 amp 2-pole breaker down a 300 amp 2-pole breaker. But they also have a 400 amp non-fused AC disconnect switch here on the grid side coming from the meter. And then immediately here I see a little bit of a tap point that goes into a double throw bypass switch. So this is this likely might be a manual transfer switch where they're going to be able to bypass the inverters if ever there needs to be any maintenance, and then they can basically just ensure that the grid feeds all of these loads. So this is definitely a good addition right here, but let's keep it on the grid side. Let's see, it goes right here from the 300 amp down to the 300 amp 2-pole grid load center, and this is the grid in. I see that I have a connection from inverters 1 all the way through 6 that are 50 amp 2 poles. Okay, so this is what I meant by the inverters being derated. The the PS50 inverters, they come with a 12.5 kilowatt inverter, which is about 52 amps, right? So we're going to want to make sure that using our PCS settings, that's power control systems, we derate the grid and the load output down to 50 amps to basically make sure that we're within limits. Okay, and so then I see the inverters over here as well. Okay, and that is pretty much it on the grid side. That's good. We're going to then take a look at the load side. So from the all 6 inverters right here, you can see up here, you can see that it's the same 50 amp 2-pole breakers coming all the way from every single inverter here to the combiner panel. And from the combiner panel itself, I see that they're going to be feeding the house 6, those backed up loads there, 20 amp 2-pole breakers, 2 of those. Then they also have that 300 amp 2-pole breaker that they're going to be basically using to feed. So they're going to be feeding here the the bypass transfer switch that on a normal position will feed their loads panels, right? So these are what they'll call the essential loads panels, where they have that 300 amp 2-pole breaker there. Okay, cool. So we are good on the load side. I did also notice that they have a generator now. This generator is going to be connected to this load center and through a 200 amp 2-pole breaker. Okay, so the generator is 34 kilowatts. That's 141 amps. So I think the only comment that I would have for that, maybe looking to upsizing the generator a little bit for a 300 amp service. This will definitely depend on the load calculations that they've performed. And so then I see also here they are each connected to the inverters. These should be connected, yep, on the gen port of each inverter. That's fantastic. Okay, so they are good on that gen side. I'd say also the only other part is to make sure that you connect that generator to all the inverters in accordance to our generator integration guide. That's definitely something to keep in mind. I see down here conduit and wire schedule, which definitely up to them to ensure that they provide that correctly. Now let's just take a look over here at the left side of the screen. I see that they have a ground mount array. Now I see that they are using 28 modules coming into a DC combiner box to the master inverter right here. And so let's see, they're using 14 modules per string. And so then they're using 2 strings in parallel. So the one comment that I would have is that for the Solaria Power X 400R, which I believe that, yep, they do have that right here, with 37.3 volts for VOC, that's going to be around 522 volts if you put 14 of those in series. And so that right there is going to be without any kind of temperature compensation, right? So if this is in California, and if this is, where it gets extremely cold, that might definitely, that might go over the 530 watt, I'm sorry, the 530 volt limit for each PS50 inverter. And so I see that basically they are putting 2 strings in parallel using that DC combiner box, and then I'm assuming that they're going to be feeding 1 MPPT. Let's just double check right here that their ISC, the short circuit current, okay, is 13.68. We can take up to 37 amps. So we just got to double this, 13.68 times 2, that's around 27, so we'll be all right on the short circuit current. And then for the IMP, that is going to be clipped at 26, and this is less than 13, so this will definitely not be affected by any clipping. That is a good design. Again, just double check the 14 modules per string. If the VOC on that with the temperature coefficient goes over the 530 volts, what I would actually recommend is I see here that you have a couple of strings with 12 modules per string, 12 modules per string, and 12 modules per string. What I would recommend is basically ensuring that these two that have 14 modules per string have 13, maybe 13 modules per string, and then add the ones that you remove from these 14 modules per string, you can add those to these 12 modules per string, if possible, right? That is definitely if possible, and also if the temperature compensation requires. Okay, so if it does go beyond that. And again, just making sure that you do have a director on site so that you are able to connect all of the PS50 inverters to the Ethernet. You want to hardwire those to have a really easy time with any kind of commissioning process. It's all connected through the network. And one thing I do want to add is that whenever you make these parallel connections for the inverters, you're going to connect, inverters, the first one to the second, to the third, to the fourth, to the fifth, and to the sixth. However, the first and the sixth are both going to have unused parallel communications ports. So you must ensure that you do plug those extra ports with the provided RJ45 resistors that come with each inverter. And you can see those here in this picture up above. That's about it for this video. If you have any questions about what I just went through, please leave them down in the comments below. I'd be more than happy to expand on any of the topics that I went over here today. I hope this video was useful, and thank you for your time. Have a great rest of your day.